Hi everyone, welcome to my channel. In this video I am gonna talk about limit concept with graphs. Let's get started with definition of limit. We say that a function f has limit value L at the point A if and only if f of x outputs tends to be L as x goes to A from right hand side and as x goes to A from left hand side. Let's explain this idea on this figure. Consider limit point x is equal to a on the x-axis. Now let's choose some points at right hand side of a. Consider this point and corresponding output somewhere here. And consider one more point closer to point A and consider corresponding value here. And as you see, when we try to approach a point from right hand side, corresponding output tends to be L. And consider another points at the left hand side of A. Consider this point and corresponding output here. And let's choose another point closer to point A at the left hand side of A and corresponding output somewhere here. As you see, when we try to approach A from left hand side, then corresponding output tends to be L. In fact, this is the graph of any function f having limit value L at the point A. Let's talk about rules of this limit concept. If you are given two functions having limit at the point L, the first one has limit value L and second function has limit value M. In that case, we can distribute limit process to addition of these functions. The first component, the first term in this addition goes to L, and the second term is going to M. In that case, limit of addition of this function goes to L plus minus M. And similarly, we can distribute limit process to this product where C is constant. Constant means here the C value is independent from the limit value, limit variable x. And similarly, we can distribute limit process to function product of functions. The first factor is going to L and second factor is going to M. That's why the limit of product of this function is L times M. And similarly, we can distribute limit process to division of this given function. And corresponding limit is L over M. Attention here, M must be non-zero. Now classify limit problems. In fact, there are two main classes for limit problems. The first one, the class of limits having no indefinite forms. For example, limit as x goes to pi over 4, tangent x approach tangent pi over 4, and we can directly compute this value as 1. And look at second example. When we directly substitute x is equal to 1 into our function, we can directly find out limit value 2 times 1 minus 1 over 1 minus 2. The answer is minus 1. And the second class is the class of limits having indefinite forms. There are four main classical indefinite forms: 0 over 0, 0 times infinite, infinite over infinite, and infinite minus infinite. For example, limit as x goes to 1, we cannot compute directly limit value, since when we substitute x equal to 1, we are going to obtain 0 over 0 indeterminate form. And as you see, the top is approaching 0, the bottom is approaching 0. And look at second example. Limit as x goes to infinite, the first factor is going to infinite, and argument of sine is going to 1 over infinite is going to 0, and sine 0 is 0. As you see, we obtain 0 times infinite indefinite form. Now briefly let's talk about elimination techniques. The first one, classical one, based on eidetic relation. Second one, L'Hopital's rule, based on derivation topic. And the final one, series expansion. In the classical technique, we use the following rules. Let's explain this rule with some basic examples. Consider this example. Limit as x goes to 2, x squared minus 4 over x minus 2. So as you see, we got 0 over 0 indefinite form when we substitute x is equal to 2 into our function. First of all, let's try to find out an expression which is identical to our function given in the question. We factorize top in the beginning. So we have obtained an expression which is identical to formula 1. When we simplify this factor and this factor, we have another expression which is identical to formula 1. So in that case, we can take limits of every term in these identical relations. Limit as x goes to 2, x squared minus 4 over x minus 2 is equal to limit as x goes to 2, x plus 2. And look at left hand side. So in the left hand side, we have 0 over 0 indefinite form. What about second limit problem? As you see, we can directly substitute x is equal to 2 into our expression, and we got 2 plus 2 limit value. Then we can directly say that limit value of this function is 4 as x goes to 2. Let's see another example. Limit as x goes to 2, 1 over 4 minus 1 over x squared over x minus 2. So let's directly substitute x is equal to 2. In that case, we have obtained this indefinite form. The top is approaching 0 and bottom is approaching 0. That's why to eliminate this indefinite form, we should find out an expression which is identical to this expression. To manage this, we multiply and divide our expression by 4x squared. Let's multiply and divide by 4x squared. These terms and these terms. And then we obtain this. When you distribute this factor into this parenthesis, we have obtained x squared minus 4 at the top, and we got this 4x squared times x minus 2. Now as you see, these and these simplify. We got x plus 2 here and 4x squared. Now we are ready to substitute x is equal to 2. Finally, we can directly find out limit of our expression, limit as x goes to 2, by using this expression x plus 2 over 4x squared times 1. Okay, we have 1 here. So which is this expression is identical to this expression. Attention here. Now that's why we can directly find out limit value by substituting x is equal to 2 into our expression. 2 plus 2 over 4 times 2 squared. The answer is 4 over 16, 1 over 4.